All right, this should be the last segment for the exam review problems. I'm going to go through 22 through 31. So 22, write the expression in expanded form. Okay, no products, no quotients, no powers when we are done. And it'll look like 23. Okay, it needs to look like that in terms of, separated by pluses and minuses. Well, when we have a division problem or a quotient, we can write that as a um, subtraction problem. So that is going to be the natural log. Let me erase that. Okay. The natural log of the numerator, which is x times x plus 1, minus the natural log of x minus 1 quantity squared. So we still have a product here, so we can split that apart into the natural log of x plus the natural log of x plus 1 minus, and I can go ahead and take this 2 and put it out in front. So we get minus 2 times the natural log of x minus 1. We are good now because we do not have any natural log of any products, any quotients, or there's no powers involved. So we are good, and that is our answer. All right, go in the opposite direction. Write it in condensed form. All right, so in condensed form, biggest thing, it is a single ln and then an expression. Okay, you cannot have multiple logs or multiple natural logs when you are going to condense form in this problem. So we take any number on the outside, we make them powers. So it's going to become the natural log of x squared, that 2 will become a power, plus the natural log of x plus 3, minus that 1/2 becomes a power, but the 1/2 power is the same as the square root. So I'm just going to go ahead and make this the natural log of the square root of 3x squared plus 2. You can have that 2 as a power. You just can't have a quantity squared or to a power. Now, since I got a plus, I can condense that as the natural log of x squared times x plus 3 minus the natural log of the square root of 3x squared plus 2. And so now that I have a minus, I can make this a division. And it's going to be the natural log of x squared times x plus 3 all over the square root 3x squared plus 2. Okay, so a single ln when we write it in condensed form. Okay, so that would be 23. All right, 24, make sure you read the problem, read the directions. We got to rewrite these as powers of the same base. Okay, we do not take the log of both sides or do anything like that. I got a 9, a 3, and 27 are my bases. They can all be written to a power of 3. 9 is 3 squared, and then that is to the power x plus 3 times 3 to the negative x equals 3 to the third power, which is 27, to the x plus 2 power. All right, I'm going to make this now. This is a power to a power, so you basically distribute that 2, and then I distribute the 3. For that. Now, when I got this here on the left hand, 3 to the 2x plus 6 times 3 to the negative x, you add exponents when we condense, okay? You add exponents. So you would basically be taking 2x plus 6 plus negative x, which is going to just give me x plus 6. So that gives me 3 to the x plus 6 power equals 3 to the 3x plus 6. Once we have got it written as a base to a power, and there's no constants in front, nothing else, we just take the powers set them equal to each other, and then I solve from here. And then I get 6 equals 2x plus 6. All right, I subtract 6 and I get 0 equals 2x. And in the end, I divide by 2. I do get x equals 0. Okay, I get x equals 0, and then we are done. So that would be that case. All right, 25, A and B. I did have a few people miss either one or both of these type of problems in the last test we had, chapter 4. Mainly because you forgot to swoop. When we rewrite it, you cannot just make this 2x minus 7 equals 2. You have got to remember, we're going to convert this to exponential form, which means 5 is my base, 2 is my power, and it equals 2x minus 7. So I have to set it up like that. That becomes 25 equals 2x minus 7. Add 7. 32 equals 2x. Divide by 2. X equals 16. Now remember, we're not allowed to take the log of a negative number. So you can get a negative answer. You just got to make sure when you plug it in, it doesn't give you a negative number. And it does not in this case. So x equals 16 is fine. Now for the second one, before I can write an exponential form, before I can do the swoop method, I have got to condense and get a single log equals a constant. So this becomes the log base 5, and then those multiply together and equal 2. So again, we run into the same case. I got a swoop, which gives me 5 squared equals, and then 3x plus 7 times x minus 2. All right, I'm going to have to FOIL and then see how I can solve it from here. I get 25 equals 3x squared minus 6x plus 7x. No, minus. What did I do wrong? Oh, this x minus 2, or that should be a 5. Oops. That should be a 5. That should be a 5. So I get minus 15x plus 7x minus 35. When I subtract 25, I'll combine like terms in the same step. I get 0 equals 3x squared minus 8x minus 60. All right, now, not always, but majority of the time, something like this will factor. I don't want you to have to go through another completing a square or quadratic formula. Typically, in this one, will factor. If I do trial and error, I'm going to make this 3x and x. These have got to multiply together to give me 60. And if I put a plus 10 here and a minus 6 here, that gives me negative 18 for my outer. Gives me 10 for my inner, which does add up to negative 8. So that is my factored form. Set both of those equal to 0. And I get 3x equals negative 10. X equals a negative 10 thirds. And then x minus 6 equals 0. X equals 6. All right, we absolutely have to check back to the original when we plug them in. Will either one of those answers give me a negative? And one will, the negative 10 thirds, when you plug it into this second one for sure. I actually think it'll give it to us in both. But when I plug it into there, it will give me a negative, so that means I got to throw it out. And x equals 6 will work. Negative 10 thirds will not. So I just get that single answer. Okay, that was 25. Not sure why it's doing that. Okay, now let's move to 26. Okay, this is a little bit more. This one's probably one of the tougher ones. You got to be careful. Write in an exact and approximate form. Now, and we talked about MyMathLab does it differently, but for your exact form, it needs to be the either log or natural log of a single number over the log of a single number or a fraction. You cannot have multiple ln's. And we'll go through here as well. All right, but 4 times 5 to the x minus 3 equals 3 to the 2x plus 3. This 4, I cannot divide. It doesn't do me any good. It's just by itself. So I need to take the natural log of both sides. So that equals the natural log of 3 to the 2x plus 3. Now, we are taking the natural log of a product, which means just like natural log of xy, you can write as natural log of x plus natural log of y. This will split apart into the natural log of 4 plus the natural log of 5 to the x minus 3. And then this one does not have a product, so I can go ahead and move that exponent out in front, and I get the natural log of 3. 2x plus 3 times the natural log of 3. All right, natural log of 4 plus now x minus 3 will come out in front as a constant times the natural log of 5 equals 2x plus 3 times natural log of 3. Okay, we need to distribute the natural log of 5 to both of those. I need to distribute the natural log of 3 to both of those. So I get the natural log of 4 plus x times the natural log of 5 minus 3 times the natural log of 5 equals 2x natural log of 3 plus 3 natural log of 3. All right, I got 3 terms on the left, 2 terms on the right. I need everything with an x on one side, everything without an x on the other. All right, I don't think there is an easy way to do this. I'm going to get the x's to the left side. That one's going to stay. This one's going to come over. So that's going to give me x natural log of 5. I'm going to subtract that equals, I got my 3 natural log of 3, and now I got to move. I'm going to add this one. So that gives me plus 3 natural log of 5, and then I'm going to subtract that to get it to the other side, so I get minus natural log of 4. So I still had a couple negatives in here. I couldn't do anything about that. But on the left-hand side, I get 2 terms with an x. Factor out an x. So I get this equals 3 natural log of 3 plus 3 natural log of 5 minus natural log of 4. Divide by natural log of 5 minus 2 natural log of 3. Natural log of 5 minus 2 natural log of 3. Now this is where we use your calculator to get the approximate answer. And you got to put the whole numerator in parentheses. But I'm just going to put it in one shot and then hit equals. I don't like to type everything in at once. So I'll do 3 natural log of 3 plus 3 natural log of 5 minus natural log of 4. So there's your numerator. I hit enter, divided by, now this absolutely has got to go in parentheses, natural log of 5, close that, minus 2 natural log of 3. Negative 11.463. Negative 11.463. That is your approximate. All right, now let's get our exact. So we're going to start with this. We're not leaving that. We got to condense it. So we get 3 natural log of 3 plus 3 natural log of 5 minus natural log of 4 over natural log of 5 minus 2 natural log of 3. Okay, so we're going to condense the top. There's two separate problems. The top is one problem, the bottom is another problem. So you have the ln on top, ln on bottom. Take the constants out in front. In all cases, make them powers. So that gives me natural log of 3 to the third plus natural log of 5 to the third minus natural log of 4 over natural log of 5 minus natural log of 3 squared. Okay, now I'm going to take it to those powers. So 3 cubed is 27 plus 5 cubed 125 minus natural log of 4 over natural log of 5 minus natural log of 9. All right, so we're condensing. Natural log of 27 plus natural log of 125 as you multiply 125 times 27, or 27 times 125, gives me 3375. So the natural log of 3375 minus the natural log of 4. Now, I'm no more powers in the denominator. If it's a subtraction, you divide. It doesn't divide into it evenly, so just make it 5/9. And now for my last step, I'm just going to simplify the top, and I divide, so I get natural log of 3375 divided by 4 over the natural log of 5/9. Okay, so that should be the exact answer. Okay, exact. Natural log of 33 over 75. Now, you might have, if you moved your x to the right-hand side over here in this step, you will get reciprocals here. What I mean by that is you will get an answer of natural log of 4 over 3375, or you should get natural log of 9/5. Both of those are equivalent and correct. Doesn't matter which one you got. All right, let's move on to 27. Find a possible function rule for the following graph. The scale on both axes is 1. Now, for your numerator, the first part we look at is your x-intercepts. Determine the numerator, where they hit. That hits at -2, so that means we have got a factor of x plus 2. This one hits at +3, so it means we have a factor of x minus 3. Your vertical asymptotes determine your denominator. That is vertical asymptote at -4, which means we have x plus 4 as a factor, and then we get 2, which means x minus 2 is a factor. Horizontal asymptote tells us the degrees and then kind of gives us the numerator. If the horizontal asymptote is not at 0, it's at 2, It means my degrees are the same, and then we look at the leading coefficients. Well, our degrees are already the same. The leading coefficients have got to be 2 over 1, so that just means I need to add a 2 in front of there. So this is going to be my equation for this one. And then we're done. All right, 28. Identify the vertical and horizontal asymptotes. All right, vertical, wherever the denominator equals 0. So x equals negative 4/3. X equals positive 2. Make sure you write them both as equations. Horizontal has to do with the degrees. Now, this top one does factor, but it doesn't really affect the problem. You could factor into 2x minus 5 and 2x plus 5, but not needed in this case because we're not graphing it. So we get 4x squared. We just over minus 25 over. Okay, if I would multiply that out, I would get 3x squared minus 2x minus 8. Same degree. We take a look at the coefficients. That means my horizontal asymptote is the ratio of the coefficients, which is y equals 4/3. Okay, real important. Vertical is always x equals. Horizontal is y equals. Cannot interchange the x and the y, so just be careful there. Okay. All right, 29. There is an a and a b. Write the given equation in standard form and identify the conic section. Well, you should be able to identify the conic section before you go any further. If you got both of them squared and you got a plus in between, it's an ellipse, not an eclipse. Okay, that's like a lunar or solar, but an ellipse with 2 L's. Now I need to group the x's together. Group the y's together. Move the constant to the other side. Now I need to complete the square on both of these. There is no number in front of the x squared, so that kind of helps out. And let me just set it up first. I do need to factor out a 4 out of the y squared and out of the 8. And let me put that there yet. And now I got negative 9 over there. And anything I put on the left, I got to count on the right. Well, I'm going to put a 9 there. Half of 6 is 3. 3 squared is 9. Gives me a 9 here. Half of negative 2 is negative 1. Square, you get 1. Don't forget you're multiplying it by the 4. So I'm going to factor and simplify. And then over on the right-hand side, I end up with a 4. It's got to equal 1. Divide by 4. That just leaves me x plus 3 squared over 4. These 4 cancels. So you can just write this as y minus 1 squared. You can put it over 1, but we don't have to, but it's going to equal 1. Okay, so there's going to be our answer for that. X plus 3 squared over 4 plus y minus 1 squared equals 1. Okay, my center, just so we know, would be negative 3, positive 1. For an ellipse, your bigger number on the bottom is always a squared. So it would be a squared equals 4. B squared would equal 1 because there would be a 1 underneath the y minus 1 squared. All right, for B, since you got a y squared and an x squared, this is a hyperbola. And now I'm going to put the positive part first. I'm going to put y squared minus 4y minus 9x squared minus 54x. Move the 86 to the other side. Make sure you make it positive. Okay, so y squared minus 4y plus. I'm going to put a spot there. Factor out a negative 9. Divide that by negative 9 as well. We get plus 6x. And I'm going to counter this on the other side. All right, in completing the square, half of negative 4 is negative 2. When I square that, I get 4. No number in front to multiply it by, so that's just a 4. Half of 6 is 3. Squared, I get 9, but it's being multiplied by negative 9, which means I need to add negative 81 total. This will become y minus 2 quantity squared minus 9 times x plus 3 squared equals, all right, we will end up with 9 over here. Got to equal 1. Divide everything by 9. Okay, now I could have just written that as x plus 3 squared, but I put it over 1, so I'm just leaving that for now. What did I say? We had a hyperbola? Yep, so we got a hyperbola. For that. Whoops. Okay, now number 30 and then 31. All right, by this equation, you just got the left side squared, and we got this negative 6. This is going to be a parabola. When the y is being squared, the parabola opens up either left or right based upon that number in front. If the number in front is negative, that a value is negative, it's going to open up left. So we got to make sure we get that. Vertex, remember it's xy, so it will be negative 3, negative 2. Vertex. To get the a value, 4a equals negative 6, whatever the constant is in front of there. A is negative 6/4, negative 3/2. So the negative tells me it opens up to the left, and I don't really worry about the negative anymore. So I just graphed my vertex. A value, since it opens up left, that means the focus is on the inside and the directrix will be a vertical line on the outside. And you go A units from the center to both of those. So I'm going to go A 1.5 to the left to get my vertex, and that's my focus, and then 1.5 to get my directrix. So the focus, the coordinates of that point, we started out at negative 3, negative 2. We moved 1.5, so that's negative 4, negative 4.5, negative 2. The directrix is a vertical line. We started at negative 3. We moved 1.5 to the right, so it's going to be x equals negative 1.5. All right, now to get to the endpoints, you take a and you double it. So 2a is going to equal 2 times, like I said, I just worry about the 3/2, which is 3. So that means we go 3 units up, 1, 2, 3, from the focus, and then 3 units down from the focus. That would be the point. Negative 4.5, 1. And now we go 1, 2, 3, negative 4.5, negative 5. So those are the two endpoints, and they give us the width of that. That goes through there as best as I could. Okay, so that's 30. You got parabola opens up to the left. All right, 31. Ellipse. That is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. Now the a squared can move based upon whether it's wider or taller. So let's take a look. Ellipse, foci, plus or minus 6. Whoops. Hold on. There we go. So at 6, I got a foci, and at negative 6. At y-intercept, so it hits the y-axis at 8 and negative 8. Your foci always lie on the major axis, so that guarantees it is wider. Since it is wider, that guarantees that a squared is underneath the x part. Now, if you take a look, the way it is set up, that the foci are plus or minus 6, that means my center is at 0, 0, which means this just boils down to x squared over a squared minus y squared over b squared equals 1. Now, the distance from the center to the foci is your c value, which is 6. The distance from the center to these y-intercepts will be your b value, because that's not going to be the vertices. It's going to be b value, which is 8. For an ellipse, c squared equals a squared minus b squared. We are looking for a squared. So we get 6 squared equals a squared minus 8 squared. When I add 64, I get 100 equals c squared. Not c squared, a squared. That's an a. So my a squared is 100, so it becomes x squared over 100 plus y squared over b squared. Well, b is 8. 8 squared is 64 equals 1. There's your final answer. Okay, there's all 31. Good luck.